Hey, sixth graders! We are finally on chapter 3, and I hope that you enjoy this next part of the lesson. And let's go ahead and get started. So, chapter 3, we are going to evaluate new information that we have from Mars, real life information that we are getting from NASA, and we are going to evaluate these claims and the evidence and see which is going to have a better supportive reasoning for us. So our chapter 3 question is, how can we decide which geological process formed the channel on Mars? So we have a lot of evidence to support claim 1, that it was flowing water, and we have a bunch of evidence to support claim 2, that it was flowing lava, and now we get to decide which geological process we think formed the channel on Mars. So we're going to remember to use this evidence card today to support our claims. So if you have not already grabbed your evidence cards, you might want to grab these and take a look at this evidence card for this lesson. And we have used these two cards to kind of gather information about what geological processes look like on Earth. So if you don't have these cards and you need them, go ahead and grab them for this lesson. Look at this evidence about these geological processes here on Earth and how we can compare it to the geological process that we're looking at on Mars. And we also used models as another piece of evidence. So we had our flowing water model, and we changed the steepness in order to gather more information about what might happen. And we also have our flowing lava model, which gave us some really great evidence about what flowing lava might look like on Mars. And so today we're really going to look at each piece of evidence, read each piece of evidence, and decide which evidence is more convincing and which evidence is less convincing. So what I mean by more and less convincing is which one of them supports it, which one of them is really going to make you say, yep, that's it, and which piece of evidence are you like, I'm not really sure. Is that really true? Is that really am I really believable? Should I let this be the reason why I'm going to say I believe this or that? So we're really going to decide which is more and less convincing. And to do that, we're going to use an evidence gradient tool, and we're going to use this throughout this school year. So it's really important that we understand what this looks like, how we're going to use it, and these are up front in the classroom when you need one. And the evidence gradient tool is going to have the most convincing information at the top, and we are going to put the least convincing information at the bottom, or evidence at the bottom. So we're going to put the things that really lead us to believe that this claim is true. We're going to put some pieces of evidence that are really, really good at the top, and then we're going to put some things at the bottom that maybe they're not so great, but they're evidence, so we'll leave them in there. So I want you to pay special attention to the evidence cards for the flowing models, so the flowing water model and the flowing lava model, and just decide how convincing are each of these pieces of evidence. And maybe the flowing water model is a really great convincing piece of evidence for claim number 1, but the flowing lava model is a better, more convincing piece of evidence for claim number 2. So when we're putting these on our evidence gradient, we have to also think about which claim we're trying to put our evidence with. So if we think that claim number 2, that it was flowing lava, then we're going to say that this is a pretty convincing piece of evidence. But if we think it's claim 1, that it was flowing water, then evidence card C is going to be a little bit more of a convincing piece of evidence. We also have all of these other evidence cards that we can add to our evidence gradient, so it's going to be nice and full, and we're going to have lots of information. So I just want you to think about what makes evidence strong and what makes evidence weak. So what makes quality evidence is how believable and accurate the source is. So what I mean by believable is, what do you think? Do you think that this is something that could be true? And then how accurate? So is it factual? Is it based on scientific evidence? Is there scientific backing to kind of support it? And does the source have bias? So if the source has a lot of bias, it might not be a quality piece of evidence. So if it says things like I think, or it might, or my opinion, those are going to have bias, and that won't make it the evidence as high quality, because that's somebody's opinion and it's not based in fact. So if a source has a lot of bias, it's going to be down at the bottom. But if it's really accurate and believable and based in research and fact, then it's going to go towards the top because it's going to be a high piece of evidence or a high quality piece of evidence. So some new information that we're going to get at about geology on Mars is that NASA has shared new information with us, and it's real data, and it's gathered from the instruments and the tools and the spacecrafts that are orbiting Mars right now. So let's look at this information. Here it is, and you have this here in your digital assignment, but I'm just going to read through it here today. So new information from NASA about the channel. Elevation of the land at the channel location. Elevation meaning that one part of it, that parts are higher or lower, so the elevation gets higher as things move up. So if there's elevation, it means that we're going to add some of that slope and that steepness. The NASA team collected information about the elevation of the land where the channel is located on Mars. This image shows that the top of the channel is a higher elevation than the bottom, and that the channel is on a steep slope. The bottom of the channel is also more flat. So we're thinking like it's at a steep slope at the top, and then it comes down, and then it's a little bit flatter. So if I'm going to make my picture bigger, and I'm going to show you. So if this is my channel, it's higher up top, it's going to come down, and then it's going to flatten out. There we go. So what do you observe about this image? What observations can you make? What noticings do you have? What questions do you have? What wonderings do you have at this time? Go ahead and pause the video and think about those things, and then you can restart when you're ready to move on. So we're going to examine these images a little bit closer up, and we are going to learn more about what the rover found. Remember that the rover is the thing that goes down onto Mars with the wheels and zooms around, and it's controlled by a little machine. So this evidence card is one that you can also have, and it's also in your notebook, and this says that the triangle-shaped landforms on Mars. Scientists found a triangle-shaped landform at the bottom of the channel on Mars. Based on the information gathered from satellites and the Curiosity rover, scientists believe that this triangle-shaped landform is made of a different type of rock than the rock around it. So let's look at the image on the left. We have the channel, and on the image on the right, there's the channel, and here's this little triangle that they see. So if you look to the left, you can see it as well, and you can see it without the lines, and it changes it. And they think that the rock inside of here is a little bit different than the rock on the outside. So we want to think about what that might mean about the model, and what that says for our claims. So we're going to make some comparison between the two landforms, the ones on Mars and the ones on Earth, and the ones that we saw from the flowing lava and the ones that we saw from the flowing water. So here's a little bit of background information on triangular-shaped landforms. Scientists use background information to support their claims, to come up to support their claims with evidence, and to support their reasoning. So let's look at this. On the left side, the triangle-shaped landform on Earth formed by water. It says when water flows down at a steep slope onto a flat area, the water carries small pieces of rock called sediment. As the water reaches the flat area, it spreads out and deposits the sediment in a triangle-shaped area. Over time, the different pieces of sediment are pressed and cemented together to form solid rock. The triangle-shaped solid rock that forms over time is called an alluvial fan. Sorry, my lights turned off in the middle of that. It's called an alluvial fan. So you can see here's the channel, and here is the kind of the fanned out part, the triangular shape. All right, let's look at the one on the right. The triangle-shaped landforms on Earth at channels formed by lava. So flowing lava can form triangular-shaped landforms at the end of a channel. These landforms are made of rock that form when the lava cools. The rock that makes up these landforms is often black in color because it is made of cooled lava. So here's our channel, and here's our triangular-shaped landform. And what they're saying here in the lava channel is that this is actually cooled lava. So the triangular shape that you see at the bottom is actually cooled lava that was moved down during the channel, during the lava flow. And again, if we look over here, this triangle on the left side with the channels formed by water, the left side, the channel was formed by pressed together and cemented together sediment. So it's also a hard rock, but it was created with sediment that was pushed down during the flowing water. So we're going to use this information to help us better understand the evidence card E, so the triangular shaped form on Mars. So you should compare these when you're looking at evidence card E. I said C, but I meant E. And you're going to use that to help you interpret the evidence that you have and that you see. So at this time, I want you to pause and think, and think about this question. Do you think the new evidence supports the flowing water claim or the flowing lava claim? After you've thought about this, go ahead and move on to your practice assignment for today and enjoy learning and making a justification and a reasoning for what you think is happening on Mars. Happy learning, and remember that today is a great day to learn.